Okay, in this problem, we're gonna try to prove this result. So we assume, or we're gonna show that if f is differentiable on R and has two roots, then f prime has at least one root. So f is differentiable, that means it has a derivative everywhere on R, and it has two roots. That means there are, let's call them a and b, two numbers in R such that f of a equals f of b equals 0. Okay, so that's what it means for f to have roots. So let's say this is my f. Okay, this is our a, this is our b. Okay, so now we want to prove that f prime, the derivative of f, has at least one root. Okay, how can we do that? So we want to see that here. So f prime can cross the x-axis on some value here. Okay, so at this value, the value of f prime is going to be 0. How can we do that? Okay, so we're going to use the mean value theorem. Okay, so we have all the conditions to apply the mean value theorem. We have f is differentiable, therefore it's continuous on R, and therefore in particular f is continuous on AB. So this one where it has the zeros. Okay, and therefore there is some c in AB such that we have f prime of c is f of b minus f of a over b minus a. So this is the condition, the conclusion of the mean value theorem. But what we know about f of a and f of b, these are roots of f. Therefore it's 0, and b minus a is different from 0. Therefore we have 0. Therefore f prime of c is 0. This one mean here. The c is in here. Therefore this means that c is a root of f prime, the function f prime. Okay, so this is there is at least one root that we have this root. It's c. Okay, sometimes we can have two roots. Okay, but our aim here is to apply the mean value theorem and see how to apply it, where to apply it. And the key idea is that to note that we have these ones, the a and b are roots. Okay, and we can apply it here because this is where we can get the c. Okay, so this is where we can get the 0, because when we have f of a equals f of b equals 0. Okay, so this is the idea behind the proof of this result here. Okay, so now we can prove more. If we can show that if f is differentiable on R and has n roots, how many one f prime can have? Okay, it must have at least n minus 1 roots. We can prove it in the same way. We can use induction, and we can use some visual technique to get the result. Okay, but to do that, we are not gonna apply the mean value theorem one time. We have to apply it many times, or write a function that would give us this c many times. Okay, so if we have more than, we have ab, but if we have a1, up to an, such f of a1 equals f of a2 equals f of an, can we find how many c's can we find? Can find c1, cn minus 1 in each of these interval. Let's say this is a1, a2, and an. We can find some c here, some c2 here, and some cn minus 1 here. And therefore, this function keeps going back and forth and crossing the x-axis and getting zeros. So this is not the aim here, but the key idea is to get this result here. Later we're gonna see how to prove the general case for this result. The main point is how to apply the mean value theorem and how to see the geometric meaning of it. That's the aim of this question. And I think that's all we need for now. If you have any questions, please comment. Thank you very much.